What questions do you have about this one? I mean, if you have none, that's okay, but. Good. Okay, let's keep going then. Let's do another one. See, we're doing good. So I'm thinking this will be the last one for today. So let's say we want to factor this one. Again, 4 terms, right? 4 terms. Try factor by grouping. Is it going to work guaranteed? Well, I want to say no, but it's really what you want to try when you have 4 terms. Okay. Well, notice that we have a non-zero constant term, so we can't factor out x at all. A coefficient is 1. So just like we've seen before, when you have a coefficient of 1, any coefficient, or a constant term, and a non-zero constant term, the GCF must be 1. I mean, essentially what's going to happen is this. Since there's a non-zero constant term, we take m to be 0. Since 1 is a coefficient, the only factor of 1 is 1 itself. So the greatest common factor must be 1. B is 1. And so the GCF must be 1. The GCF must be 1. Okay, so what do we do? Again, notice here we have subtraction between the second and third term. I like to make it into addition. That's what I'm doing here. I make it to adding the negative. I mean, if you don't do that, that's fine. You do have to be careful with parentheses. That's why I tried to show in an earlier example. You got to be careful when you put the parentheses in. Also, once we form those 2 groups, the second and fourth term have opposite signs. So we will have to factor out a negative from the second group. You know, the 2 groups, we take the first 2 terms, that makes a group. The next 2 terms make another group, as you can see. Okay, that's great. Let's now factor each group individually. Okay. So we're going to factor each of these groups individually. Okay. Now, for the first group, right here, the smallest power of x is 2, as you can see. Right, so m is 2. Smallest power of x is 2, so m is 2. A coefficient is 1, right? Well, if the coefficient is 1, the greatest common factor among the coefficients must be 1. So we factor that. So in that GCF notation, B is 1, M is 2. Okay, that's good. So what we get then is for the GCF of this group, of this, this, we have 1 times x squared, which is just x squared. That's what we get. So with the first group, the GCF is x squared. Let's factor it out. We have it in front, and then we divide to see what's left over, right? When you divide into each term, as you can see. And when you divide into each term, right? That's how you divide. The first quotient gives you x. The second quotient gives you 2. So this is the first group. Okay, that's good. Next, we handle the second group. So all I did here was I took what we got for the first group, right, down here, and I put it in. Well, for the second group, well, there's a non-zero constant term. So we can't take out x at all. So m is 0. If you look at the factors of 7 and 14, 7 is a factor of 14, as I have written there. Right down here. Factors of 7 are 1 and 7. Factors of 14 are 1, 2, 7 and 14. So 7 is the greatest common factor among the coefficient and the constant term. I mean, you can always list the factors if you want. What I'm trying to illustrate is you don't have to. So, because 7 is a factor of 14. So 7 is the GCF. But again, since the second and the fourth term, right, they're opposite in sign. One's addition, the other is subtraction. We must factor out a negative from the second group. So we factor out -7. That's what I'm doing here. Okay, so we have -7 in front, right? We divide to see what's left over. When we do that, we're going to have -7x over -7. Okay, -14 over -7. And of course, there'll be some cancellation. You'll get -7 over -7. Those cancel, you'll get x. And then you're at +2. Right, so now both groups, right, when we substitute this in, you can see both groups have an x + 2. Hold on, go back. Right, both groups here, right, we have this from before. We factored this to get x -7 times x + 2. So there is, so in parentheses, we have the same thing, as you can see. We have x + 2. So that common thing, we are going to take it out. We're going to factor it out. So we can factor that out. Okay, so factor it out. We divide to see what's left over. That's exactly what I'm doing, right? We divide it into each term. Cancellation, and we get this. So that's what we get here. Now, x + 2, you actually cannot factor that any further. X squared -7, you can't either, because 7 is not a perfect square. Only if you have a difference of perfect squares can you factor that. Okay. Any questions on this? Yeah, what questions do you have about this? I know, again, this is not easy. I understand. I do. All right, I guess we'll see the next one. See, the next example I was going to have everyone do is one they would try on their own. But we have about like 1 minute and 15 seconds. And I don't want anyone to rush through this. I mean, then we'll see more examples. So I'm guessing this is probably a good place to stop. This is what I got up to in the other class anyway. So I guess we'll stop here then. Let me stop the recording.